Hello, welcome to the Chapter 5 Study Guide video. So if you haven't studied all week for your Chapter 5 Study Guide, I am here to help. So let's take a look at the first problem. What is the value of x in the figure at the right? So here is x, okay? And then if we look, we know in this tree we have a few angles here, okay? And what we want to know in this particular type of problem is that we have angles that are on the same side of the transversal, okay? And what we always say is it's in the same spot on a different tree. That means they're congruent, and these are corresponding angles. So x is 118 degrees by corresponding angles, okay? A couple other thoughts. Well, maybe we'll take a look at it in example 2. So which pair of angles is not congruent? I'm not going to list them all, but a couple of thoughts. 1 and 3 are congruent because they're vertical. 2 and 4 are congruent because they're vertical. Same with 5 and 7 and 6 and 8. Those are all congruent because they're vertical angles. We also know alternate and interior angles. 4 and 6 are congruent. 3 and 5 are congruent. And then we can do all the corresponding. 1 and 5 are congruent. 2 and 6. 3 and 7. So all of those are congruent. So what you're looking for is a set of angles that aren't congruent. They can be next to each other because they're supplementary angles. So we could say angles 1 and 4 are not congruent. We could say 2 and 3 are not congruent. 2 and 3 are not congruent. Okay. Maybe from another tree. So I did some supplementary angles here. We could even say 3 and 6 are not congruent. Okay, they're also supplementary consecutive interior angles. So there's lots of options there. You just want to make sure you know your congruencies and make sure you don't pick one of them. All right, number 3, there's a few ways to do this, but as I walk through this with a few of the kids in class, I think the easiest thing that they saw was that all 3 made 180 degrees. Now, if you do see that 1 and 2 will make a 90-degree angle, you can maybe do this slightly faster, but not many kids saw that, so I'm going to do this. In the figure below, measure of angle 1 is x, so I filled that in. Measure of angle 2 is x minus 4, okay? And we know that 3 is 90 degrees, all right? And so what I'm going to do is I'm going to do this problem using the 180 degrees because, like I said, that's what most kids saw right away. And what we want to do is we want to write a statement that could be used to prove that x is 47. Okay, so we want to see if x is actually 47 degrees. So I know that since angle 1, 2, and 3 together make this straight line, which measures 180 degrees, I can add all 3 of these up, set it equal to 180, and then solve for x. All right, so x, that's the measure of angle 1, plus x minus 4, that's the measure of angle 2, plus 90 equals 180. All right. Now, before I do any of what I call algebra moves, adding or subtracting, multiplying or dividing to both sides of the equation, I need to combine like terms. All right. Distribute is usually what I say in combine like terms, but there are no parentheses here, so we don't have to distribute. X plus x is 2x. Okay. And negative 4 plus 90 is positive 86. And that still equals 180. All right. Now I can subtract 86 from both sides, which is 94. So 2x equals 94. I'm going to divide both sides by 2. And I'm going to get x equals 47. There, I just proved that x does in fact equal 47. A lot of you said they were both 45. That was your initial assumption because it looks like this angle here kind of bisects this 90-degree angle, but it does not. It's close. 47 is close to 45, but you don't want to make that assumption. Okay? All right. We're Use the stick to draw a right triangle in the ground. The hypotenuse of our triangle is 24, and one of the legs is 12. So this is, I see the word hypotenuse, I'm thinking Pythagorean theorem right away. And to help me, I'm going to draw it. All right, so I'm going to draw any triangle, any right triangle. And I know that opposite the right triangle, so the side that doesn't make the right angle is the hypotenuse. And from the problem, it says the hypotenuse is 24 inches. Okay, and one of the legs is 12. I don't care which one we put as 12. I'm going to put this one. All right, and now I'm going to set up the Pythagorean theorem, which says the leg squared plus the other leg squared equals the hypotenuse squared. All right, and I'm going to go through and square those two numbers, and I'm going to get 144 plus b squared equals 576. Okay, now I have to solve for b squared. So because we knew the hypotenuse, this problem is like one more step to solve than when we know both the legs. So that extra step is right here, subtracting the leg from the hypotenuse squared. And I get b squared equals 576 minus 144 is 432. All right. Now, b is not by itself yet. It's squared, so the opposite of squaring b is square rooting b. And whatever I do to one side of the equation, I have to do to the other. And I'm going to get, let's see here. 4 point, that can't be right. Let's see here, let me try that again. So 432 square root 432 is 20.8. 20.8, which would be this side right here, 20.8. Okay, and that's number 4, 20.8. And we prove number 3 up here, so I have it right here. All right. Let's see, now we're back to two parallel lines cut by a transversal. So in the figure at the right, if angle 6, so I'm going to fill it in, find the measure of angle 6 if the measure of angle 2 is 75 degrees. So we know that's 75. This is a corresponding angle as well. So we have our two parallel lines cut by a transversal. All right, so we have a tree here. We have 4, 3, 2, and then 1, and then this 50-degree angle is part of our tree. And then we have 8, 7, 5, 6, so same tree, or I'm sorry, same position on the different tree. So 2 and 6 are corresponding, so 6 is 75 degrees. Ooh, I missed one. All right, what is the measure of an exterior angle of a regular hexagon? What is the measure of an exterior angle of a regular hexagon? So, what we want to do for these problems is to take the number of sides. So a hexagon has 6 sides. Hex means 6. 6 is the unlucky number, so I put a hex on you, hexagon, so that has 6 sides. And all of the exterior angles add up to 360 in any polygon, any shape at all. Okay, so I'm going to take 360. I'm going to divide that by 6, the number of sides, because that's how many exterior angles it'll have, and that is 60 degrees. That's number 5, 60. So I actually went from 6 back to 5. I apologize. All right, what is the value of x in the triangle at the right? We know that all of the angles in a triangle add up to 180 degrees, so I just have to add these together. 2x plus 75 plus 65 equals 180 degrees. All right, how much time? Good. I got to combine like terms, so there are no other x terms, so he's not going anywhere yet. And 75 and 65 is 140, which equals 180. Ooh, positive 140. There we go. I'm going to subtract 140 from each side. I'm going to get 2x equals 40. Therefore, x equals 20. So I'm going to divide both sides by 2. X equals 20. All right, let's take a look at the last page here. I don't know if I can finish in the 5 minutes I have left, but we'll give it a shot. This might have to be 2 videos. So find the sum of the measures of an interior angles of a 21-agon, so that means it has 21 sides. The formula for that is n minus 2, n is the number of sides the shape has, times 180. So 21 minus 2 times 180. All right, that's 19 times 180, which is 3,420. It doesn't say regular 21-agon, so I don't have to find. It doesn't ask me for one angle, just all of them, and that's what it is. All right, I see a triangle. It's probably a quadratic. Let's make sure. In a diagram, George let go of the string tied to his balloon. Write and solve an equation to find how far above George's head the balloon is. Round your answer to the nearest tenth if necessary. So we have the hypotenuse. Remember, it's opposite the right angle. We have one of the legs. We're missing a leg. So we know, let's say, a squared. We got to find b squared. So 80 squared plus b squared equals 95 squared. You guys probably want to call that x. I should probably call it x too, because that is the variable in the problem. All right. So 80 squared is 6,400 plus x squared equals 95 squared, which is 9,025. I'm going to subtract 6,400. X squared equals 2,625. I am using a calculator for these, so I'm going to square root both sides. Second square root of second answer is x equals 51.2. 51.2. And that makes sense, at least a little, because we have a side length of 80, 51.2, which is also less than 95. So at least one little check you have is to make sure that your hypotenuse is still your longest side, which it is. All right, pentagon building. So I'm assuming this is going to be a side. That's five-sided. It's named because it is in the shape of a regular pentagon. What is the measure of each interior angle? So because it's regular, all of the angles are congruent. So if we find the sum of all of them, which goes back to here, we can then find it for an individual by dividing by 5. So we're going to have 5 minus 2 times 180. So that's the n minus 2 times 180 formula, which is 3 times 180, which is 540. All right, if I take that and divide it by 5, so that is all of them together, and each is the same, so they're all equal, so I can divide that by 5 because it has 5 sides. That's going to give me 108. So each angle, interior angle of a regular pentagon is 108 degrees. Ooh, 2 minutes. Maud's living room is in the shape of a rectangle, 21 by 14. Find the diagonal. So I'm going to draw it. Okay, I know it's 21 by 14. Okay, and I got to find this guy. That's the hypotenuse. So I need 21 squared plus 14 squared equals c squared. We'll call that c. Okay, 21 squared is 441 plus 14 squared is 196 equals c squared. C. All right, I add those together. Plus 441 is 637 equals c squared. I'm going to find the square root of that, which is 25.2. 25.2. All right, I got a minute to finish this last problem. Find the distance between the points. That's the distance formula. All right, which is, I'm going to write it, pause it, and then write this. So, all right, so there it is. It's the difference in x plus the difference in y squared. So I'm going to subtract, square these numbers, and then add them together. Remember that when I square a number, regardless, it's going to be positive. So I'm not going to get any negative values under the radical. All right, so I'm going to call this x1, y1, x2, y2. So I'm going to subtract my x's. 6, I don't know if I'm going to finish, 6 minus 10 squared plus, oh, those are the y's. Oh, I screwed that up. Son of a gun. Thinking too fast. All right, here we go. 10 minus plus 4, because I'm subtracting, squared, plus negative 5 minus 6 squared. And I don't think I'm going to finish. I might have to do this one on the next problem. I would square root that. Okay.